Um, good evening, everyone. Welcome, all of you. Very, very good evening. All right. Please once confirm if you can all hear me properly. Very good evening. Very good evening. So, yes, guys, हमारा जो session था, last session, that was on organic reagents and name reaction. There is one more session on the same topic which remains. तो वो session हम आज रात को 8:30 बजे करने वाले हैं, 8:30 p.m. All right. So we are going to continue our discussion on organic reagents and name reaction at 8:30 p.m. today. And 6 p.m. ko at this time, we are going to do some questions on pericyclic reactions. Right. Is that fine? Okay. And also, if you have not seen, मैंने कुछ session pre-plan करके रखे हुए हैं. So you can just go through my channel. जो live section है, you can go through over there. So there are some live classes which are scheduled. The timing is same, 6 p.m. every day, so that you can see all the live classes. Okay, आपको वहाँ पे जाके सिर्फ register करना है. You will be notified if you are already subscribed to the channel. Okay, right? So yes, since everyone is here, let's start the practice. Let's continue the discussion. Yes, किन्होंने join कर लिया है? शुभदीप, परेश, दिशा and everyone. Good evening once again. All right. Yeah, my voice is clear. Please once confirm. चलो. So last session में एक question हमारा रह गया था. I said कि ये मैं दोबारा discuss करूँगी इसको. So this is a question from December 2019 question paper. Okay, how many of you have done this question? इसका answer option number 3 था. How many of you have tried out the mechanism? Tell me once. Right. So, have you tried out the mechanism for this question? थोड़ा सा ये tricky है देखो. As I said, first step, I'm not writing the whole mechanism again क्योंकि ये बहुत लंबा चौड़ा जाएगा. So, in the first step, in the presence of an acid, it is going to form an enol. Enol का proton यहाँ से निकलेगा, ठीक है? So, it is going to form the enol from here. After the enol formation, it is going to do Michael addition over here, ठीक है? So, I will directly write the product. What is it going to look like after Michael addition? This carbonyl should be as it is. This is bromine. There is CO2Me over here. ठीक है, यहाँ से connect होगा. Michael addition करके, this is your molecule, what we have got. So we have 1, 2, 3, 4, 5, 1,5 dicarbonyl, which again in the presence of acid is going to also give you aldol reaction. Intramolecular aldol. So it is Michael addition first, aldol reaction next. ठीक है? Yes, exactly. वो उसको करने के लिए exactly युवराज यहाँ पे एक चीज थी कि अगर हम if we are doing quasi favors की we need bromine also, we need carbonyl also. So if we are doing aldol condensation, वो हम कहाँ से करेंगे? From where are we going to do aldol condensation? There is no more proton remaining over here, and as compared to these two, ये proton ज़्यादा acidic है. This is a more acidic proton as compared to any of these. So चलो यहाँ से कर लेते हैं, ठीक है? So if we are doing so, it is going to, from here if the enolization takes place, it is going to attack over this carbonyl. How many membered ring? See these 1, 2, 3, 4, 5 and 6 membered ring is going to form, which is kind of going to be a little bit difficult to write. ये CO2Me यहाँ लिख देते हैं. ऐसे करके ये 3 कार्बन आ गए इधर, and there should be your carbonyl over here. So but the carbonyl is now going to become OH, so let's write it OH over here and one more methyl, and here you have one more bromine connected. All right, so this is how the aldol reaction is going to be. Okay, क्योंकि Br के साइड पे ज्यादा acidic proton है. After that Since we are trying out quasi-Favorsky, what is quasi-Favorsky? It is not a proper Favorsky reaction. Why? Because in a proper Favorsky rearrangement, we need alpha halogen on the one side and on the other side we need a hydrogen. यहाँ पे hydrogen है नहीं निकालने के लिए, तो ये quasi Favorsky बोलो या semi benzylic rearrangement बोलो, that the base is going to directly attack over this carbonyl. ठीक है? How does it directly attack over the carbonyl? Because see, if it directly attacks like this bond can open up on this side. अगर ये ऐसे open करता है bond, तो देखते हैं क्या मिलेगा. This side you still have the bromine. Everything will be the same. Just that the carbanion goes on this carbon where there is this ester. ठीक है? ऐसे करके. Now we have COO and this nucleophile, whatever it is. I'm writing it as a nucleophile. Okay. Now this minus charge is going to attack over here on this carbon because there is a leaving group and the Br is going to leave. तो एक नया bond बन जाएगा यहाँ से. This is a new bond which forms. How many membered ring? 1, 2, 3, 4, 5. A 5-membered ring on this side and another 5-membered ring on the other side. ठीक है? So that is what you're going to get. Also, just one second, after the aldol reaction, we did not remove this OH and the H. तो यहाँ से एक proton और OH भी remove करना है हमें, so that we get this double bond over here. And this is going to be your carbonyl connected to this strong nucleophile or a base over here. ठीक है? And the other side is ester. So quasi-Favorsky के लिए हमें ये चीज चाहिए CO alpha position पे Br. This is only possible if we are doing aldol reaction from this side. Okay, so 3 is the correct answer. Michael followed by aldol followed by quasi-Favorsky. More such questions we will be doing at around 8:30 PM today. ठीक है? क्योंकि reagent वाला session अब 8:30 PM को करेंगे. अभी pericyclic के question कर लेते हैं because the session was scheduled. And tomorrow same timing we have one more session of pericyclic. ठीक है? 6 PM पे. चलो, intermediate A and the major product B formed in the following reaction. Again. Alright, so what kind of a reaction is this? कौन सा reaction involve हो रहा है यहाँ पे? Which pericyclic reaction? Alright, there is heat. What does this heat involve? Yes, try out everyone. बहुत ही आसान सा question है ये. So basically in this pericyclic topic, there are many previous year questions which have been asked from the books and most of the important questions are covered. अब हमें भी पता चल गया है कि बहुत बचे कुछ एग्जाम्पल है बुक के अंदर, तो अगर आप लोग बुक फॉलो करते हैं तो आपको पता चल जाएगा that what are the important questions or examples which are remaining which have not been asked yet. Sigma tropic, is it? चलो देखते हैं. What do you have first of all? methyl iodide and a base. तो what is this methyl iodide going to do? नाइट्रोजन के पास लोन पेयर है. It can attack over methyl iodide like this. I minus goes away. DBU strong base. तो अल्फा पोजीशन तो यहाँ है. This is the alpha position with respect to this carbonyl. So this alpha proton is going to be acidic and it becomes even more acidic. See, when we are having a methyl like this, nitrogen gets a positive charge. Now these two protons are even more acidic क्योंकि एक side carbonyl है, दूसरे side minus I effect of nitrogen. So very very acidic they'll become. So that's why we are going to have a positive on nitrogen and negative like this. ठीक है? Okay. How many bonds are present over here? See, 1, 2, 1, 2, 3. So this is nothing but a 2, 3 sigma tropic rearrangement. ठीक है? Guys, when you study from a proper book, you will be able to know have any other species जिसमें charge है. All right. So right. So यहाँ पे हमारे पास quaternary ammonium salt है, which is just simply going to give you rearrangement like this. First option is wrong because of wrong charges. Again, this is wrong because of wrong charges. Either it is 2 or it is 4. Now, what is the important thing that you have to consider? Stereochemistry. Stereo of these groups. Okay. So, all right. Taking care of these two. ये जो ester और ये जो methyl group है, they are trans to each other in the original molecule. So even if you rotate, even if you let's say we are rotating this, but we cannot change the stereochemistry. The relative stereochemistry cannot be changed. ये भी trans है और ये भी trans है. They are basically pointing outside. Okay? इस तरीके से अगर हम इसको लिखते हैं, all right, then a new molecule is going to form which is going to look like this, and the stereochemistry is going to be trans. It cannot be cis because these two groups are pointing in the opposite direction in this way. Okay, if they were close to each other, let's say ये ester group यहाँ होता या methyl अंदर की तरफ होता तो हम सोचते cis हो सकते हैं, but now they will be trans. Answer is option number 2 for this. Okay. Chalo, moving onwards. Another very simple question. Major product formed in the following reaction. All right, what is the reagent over here? Good evening, everyone who are joining now. Shivani, Srijita, everyone, Logesh. All right, आज पेरिसाइक्लिक कर रहे हैं 6 बजे और रिएजेंट के क्वेश्चन 8:30 बजे होंगे. ठीक है? I hope that preparation is going on good. All right. So, what is the major product in the following reaction? Very simple. Yes. All right. Very simple. This one. Very, very simple. So basically, this molecule is going to react with the nitrogen and the carbon double bond. SO2Cl is going to be as it is. तो ये इसके साथ react करने वाला है. ठीक है. After that, it's going to give you simply this molecule. It's a simple cycloaddition reaction. उसके बाद आपको क्या मिलने वाला है? N. Let's say हमने N इस तरफ add कर दिया, एक ही बात है. So this side there is going to be this carbonyl. So this is going to be NSO2Cl, and here in the next step you have aqueous Na2SO3. What is this used for? This is used for deprotection of this group, क्योंकि ये reversibly add होता है. So that's why you're going to have the amide bond now. You have NH simply. So answer is option number 4. ये तो कुछ ज्यादा ही easy question था. ठीक है, चलो आगे चलते हैं. Okay, following conversion involves. Look at this question, very simple. Alright guys, I think the video has stuck. Is that so? Video stuck हो गया है ना? Alright, तो काफी easy question है ये. Right, the following conversion involves. You see, there is a base. Very simply, when you have a base can remove a proton. ये proton easily removable है. Why? Yes, because here we are going to push this Cl off, and there is a nitro group at the para position. Okay, so this is going to be somewhat like this. एरोमेटिक ग्रुप, इसको हम एरोमेटिक लिख देते हैं. यहाँ पे माइनस, यहाँ पे पॉजिटिव. ये क्या बन गया है? ये एक 1,3 डाइपोलर स्पीसीज बन गया है. दिस इज अ 1,3 डाइपोलर स्पीसीज, नॉट जस्ट अ सिंपल कार्बा एनाइन. ये सिंपल कार्बा एनाइन नहीं है. ओके, सो वी आर गोइंग टू मूव ऑनवर्ड्स विद दिस. आफ्टर दैट वी हैव अल्काइन. अल्काइन का एडिशन हो जाएगा. All right. So the alkyne adds like this to give you this molecule. So you are having what kind of a reaction? 1,3 dipolar species formation followed by a cycloaddition reaction. 3 plus 2 cycloaddition. Okay. काफी simple question था. Let's move onwards. Okay guys, ये IIT JAM का question है, but this is my favorite question. Okay. It was asked in IIT JAM. But every time whenever I teach pericyclic, I always take this question. क्योंकि ये pericyclic, aromaticity दोनों का mixture है. How is it 1,3? See, whenever you have a reaction possibility for three different centers which are written like this. This is a pH. There is a triple bond. It is actually a cyanide, but it is not also a cyanide क्योंकि यहाँ negative है, यहाँ positive है. So actually These three are reacting. Okay, whenever you look at ozone, then you see oxygen has a positive charge, this one has a negative charge. But eventually, whenever you are reacting ozone, these three will react. इसका एक Lewis dot structure अगर लिखना है, one more resonating structure if you want to write, you can write it like this also. There is one negative and carbon पे positive है, you can also write it like that. Nitrogen has a lone pair. Eventually, these three are involved. So that's why it is a 1,3 dipolar species. Okay, Logesh, I think I've answered your question. Now let's answer this one. अच्छे से देखो शुभादीप एक बार फिर से, क्या बोल रहा है क्वेश्चन? एक्टिवेशन बैरियर. It is asking activation barrier. Yes, रितिका A. चलो देखते हैं. Guys, activation barrier follows the order. Simple सी चीज है. The one which is more reactive will have less activation barrier. Yes or no? Who is the most reactive? This first one is the most reactive. Why? क्योंकि यहाँ पे resonance energy overcome नहीं करनी पड़ रही है. This molecule is not aromatic in nature. It is just a cyclic diene. But we look at furan. It is a aromatic molecule. Thiophene aromatic and pyrrole aromatic. Who has the maximum aromaticity? 3. This has the maximum resonance energy. और इसीलिए ये सबसे स्लो रिएक्ट करेगा. then comes 4. 4 has greater activation, or let's say greater resonance energy as compared to 2, or 1 is going to have least energy क्योंकि ये aromatic नहीं है. तो आपका आंसर ये रहेगा. This is going to be activation energy. Higher the activation energy, lower is the reactivity. Higher the activation energy, lower is the reactivity. If you ask me कि what is the reactivity order, तो इसका just opposite होगा reactivity order. Reactivity order is 1 greater than 2, which is furan, greater than 4, which is pyrrole, greater than 3. इस तरीके से. ठीक है? So this is going to be the reactivity order. Alright? So the answer is option number C over here. That's how it is. Now we move onwards to another very beautiful question. ये question पुराना है, no doubt, but ये stereochemically काफी अच्छा है. So I took this question. So what can happen in the presence of heat? Thermal condition में क्या हो सकता है यहाँ? All right. D are you saying? चलो चेक करते हैं. D or B or C, whatever it is. What is this reaction? क्या reaction है यहाँ पे? In the presence of heat, we can have a 4n ring opening. Thermal 4n ring opening. How is that so? ये देखो, ये ring ऐसे खुल सकती है. So 4-membered ring is going to open in the presence of heat in a con-rotatory manner. ये ध्यान रखना है बस. After ring opening, it is going to give you a diene in this way actually. Okay, the ring is going to open in such a way कि एक diene बन जाएगा. Now, what is the stereochemistry? Con-rotatory है. See, actually, if this ring is to be considered like this, कि एक group ऊपर की तरफ है, this methyl वाला group, this is above the plane and the other methyl is below the plane like this. ठीक है? Then how con-rotatory is going to move them? Either you move them in this direction, ये भी con-rotatory है. If you are doing that, you are going to move it like this. Since both the methyls are on the same side, take care of this. तो ये ऐसे move कर जाएंगे inside, and this one also is going to go inside. So basically, let's say this is moving in this direction, तो ये भी इसी direction में move करेगा, ये हो जाएगा ऐसे. This is one possibility. यस, मैंने इसको ये वाले एरो से फॉलो करवाया, मैंने इसको बीच में लेकर आया. दो पॉसिबिलिटी में से द मोर क्राउडेड पॉसिबिलिटी आई एम सिलेक्टिंग. व्हाई? बिकॉज ओनली देन यू कैन अंडरगो वन मोर रिएक्शन. व्हाट इज दैट वन मोर रिएक्शन? 4n+2 रिंग क्लोजिंग रिएक्शन. अगर ये मोर क्राउडेड पॉसिबिलिटी आती है, देन वी कैन गो विथ वन मोर electrocyclic ring closing 4n+2 thermal, that is going to be disrotatory. ठीक है? So the disrotatory ring closing is going to look like this. ठीक है? One of the methyl, this one is going to be planar, और इन दोनों methyls की stereo हमें check करनी है. So there is one hydrogen and another hydrogen outside, both the methyls are on the same side. ठीक है? सो डिसरोटेटरी मोशन मतलब कि अगर ये सेम साइड पे हैं तो ये किस तरीके से हो जाएंगे? यस, सी, दे आर ऑन द सेम साइड. डिसरोटेटरी मोशन विल गिव यू ट्रांस. So either you keep them trans like this or you keep this one above, this one below, doesn't matter. हमें ट्रांस चाहिए. ऑप्शन नंबर ए और ऑप्शन नंबर बी में ट्रांस है. ऑप्शन नंबर ए का मिथाइल पोजीशन इज रॉन्ग. ऑप्शन नंबर बी मिथाइल पोजीशन इज करेक्ट. इट इज नॉट गोइंग टू बी डी because they are already on the same side. अगर opposite होते तो opposite and disrotatory will give you cis, ODC. It will give you cis. But since they are on the same side, pointing in the same direction, this gives you T. Now this is a little bit tricky, guys. I don't know if all of you can actually decide whether they are on the same side or not. Tell me, ये समझ में आता है सबको कि ये दोनों मिथाइल सेम साइड पे है कि ऑपोजिट है? दीज टू, कैन यू सी, आर यू एबल टू अंडरस्टैंड दैट? yes or no, whether they are same or not? because this is the most important thing. ये determine हुआ, उसके बाद ही we can predict the product. In question, methyl is dashed. I know, Shrijita. Okay, sorry, Shrijit. So see, I have two possibilities. One possibility is push these two groups outside, and the other possibility is to bring them inside. I have brought them inside. ऐसे करके I have brought them inside, because if it comes inside, then only it is going to become this kind of a system. Okay. When I push them inside, both of the groups are inside. Yes, both of the groups are inside. Now, I have hydrogen pointing outside, I have this hydrogen pointing outside. So these two hydrogens are on the same side. तो फिर मिथाइल भी same side में होंगे ना, इसीलिए same and this rotatory gives you trans. So that's why B is the correct answer. Okay, all right. I hope that this makes sense to everyone. Let's move onwards. ये बहुत ही ज़्यादा अच्छा question है, because it might take some time, but this is going to open up your mind about stereo, about the mechanism. Sequential reactions. कौन से sequential reaction possible है? Yes, Shivani, you're asking me to repeat how you decide to move. First thing, I can move them outside. Outside move करूंगी तो ये वाला arrow follow करना पड़ेगा. ठीक है, अगर ये arrow follow करेंगे तो इस तरीके से ये खुल जाएगा ऐसे. ठीक है, ये ऐसे चले जाएंगे दोनों, एक दूसरे के ऑपोजिट चले जाएंगे दोनों. पर अगर हम इस बॉन्ड को ऑपोजिट रखेंगे तो ये फिर से साइक्लाइजेशन नहीं कर सकेगा. बीच का जो एल्कीन है वो ट्रांस नहीं हो सकता. ठीक है, अगर होगा तो ऐसे वापस से साइक्लाइजेशन नहीं होगा 4n+2. तो ये पॉसिबिलिटी कैंसिल कर दी हमने. दूसरी पॉसिबिलिटी है दोनों को अंदर ले आओ. तो वो अंदर लाने के लिए हम दोनों को, क्योंकि कॉन रोटेटरी है, दोनों एक ही डायरेक्शन में जाएंगे, इसीलिए हम दोनों को अंदर ले आए. ठीक है, ये बेसिकली एरो तो सेम ही चल रहा है ना, एंटी क्लॉकवाइज. गॉट इट? यस शिवानी, आई होप दैट नाउ इट इज क्लियर. ट्राई टू डू दिस क्वेश्चन बाय योरसेल्फ. ये पुराना क्वेश्चन है पर बहुत इंपॉर्टेंट है. आ जाओ, दूसरे में आते हैं. यस. All right, everyone, done. Let's see, what do we require in a Claisen rearrangement? Claisen में हमें क्या चाहिए? Claisen में हमें चाहिए एलाइल विनाइल ईथर. एलाइल विनाइल ईथर. Okay, this is what we want in the Claisen rearrangement to happen. But let's see if we have a allyl vinyl ether. Allyl vinyl ether नहीं है, क्योंकि ये देखो, this is the allyl portion, because there is one sp3 carbon in between, but this side you don't have vinyl ether. This is again another allyl ether. That's why a Claisen rearrangement is not possible. तो हम क्या करेंगे? We will look for cope rearrangement first. Cope के लिए we require 1,5-diene. हाँ, 3,3 sigma tropic तो है anyway, but which 3,3? Like this. We need 1,5-diene. चलो देखते हैं मिल जाएगा क्या. ये देखो, 1, 2, 3, 4 and 5. You have a 1,5-diene. तो पहले cope rearrangement करेंगे. कोप रीअरेंजमेंट के लिए व्हाट वी शुड डू इज यहाँ पे लिख देते हैं मिथाइल और यहाँ लिख देते हैं ये डबल बॉन्ड बिकॉज आई एम जस्ट चेंजिंग द पोजीशन ओके सो दैट वी कैन डू दिस रिएक्शन इजीली. ये बॉन्ड यहाँ खुल गया. ऑल राइट, आई होप दैट यू आर गेटिंग दिस. ठीक है, ये वाला बॉन्ड खुल गया है बीच में से एंड द next bond is as it is. Now you are getting one allyl vinyl ether. Okay, now you have got allyl vinyl ether because you see this is the vinylic ether bond and this is the allylic ether bond. So now you can do a Claisen rearrangement. ठीक है, तो चलो we will do a Claisen rearrangement over here. There is a carbonyl on this side and to this atom allyl group is going to get connected. ये यहाँ पे आ गया allyl group. ठीक है. Now next thing that we see is ene reaction. How do we try out an ene reaction? ये देखो ene reaction हम कैसे कर सकते हैं. All right, so this carbonyl CO is going to take away this proton. ठीक है, ये carbonyl के पास ये proton आ जाएगा and we are going to push the bonds in this way such that this carbon is going to attach over here. ठीक है, और ये क्या करेगा, ये carbonyl oxygen जो है this is going to take away a proton. So you are going to get exactly this molecule. ठीक है, this allylic group is as it is, ester is as it is. There is going to be one more junction. ये एक नया junction बन जाएगा यहाँ पे. Okay? ऐसे करके. All right? And this is going to become an OH. This has become an OH. And the rest of the molecule is as it is. So we are first doing a cope rearrangement, then Claisen and then ene reaction. Answer is option number B. All right. So everyone who has answered B is absolutely correct. Very nice. Very nicely answered. आज का हमारा ये last question है pericyclic वाले session का. That when we are having such a molecule, 2 E alkenes and 2 दो trans और दो cis alkene हैं in this 9-membered system. Now, what will happen in the presence of light and heat? What is the more probable possibility? All right, this is our last question for today, and then we have another session at 8:30 p.m. Okay, try out one more possibility. Look at option number 3 if it is possible. 2 possible है, correct है. 3 को भी try करो, क्या ये possible है? And if you say कि 2 and 3 both are possible, which is more possible? So 4n thermal condition is going to be con-rotatory ring closing. ठीक है, तो लेट्स से थर्मल कंडीशन है और ये 4n मतलब 8 pi इलेक्ट्रॉन सिस्टम हो गया है. So if we do con-rotatory, if we just do the ring closing over here, involving all of the 4 bonds like this, con-rotatory में trans हो जाएगा. It is going to form an 8-membered ring in this way, but the junction is going to be trans. This hydrogen here and this hydrogen here. ठीक है, तो ये हो जाएगा. कोई बात नहीं, वो कोई बात नहीं, डबल बॉन्ड की कोई दिक्कत नहीं है. आई विल जस्ट पुट इट ओवर हियर in all the options. Okay, so yes, you are going to have, if we follow this, option number P is going to be like this, because it will be a 3-membered ring with a trans junction. तो इतनी छोटी रिंग का ट्रांस जंक्शन मुश्किल ही पॉसिबल है, पॉसिबल नहीं है. इसीलिए 2 करेक्ट है क्योंकि ये हो सकता है. But if we try out another possibility in the same question, that here we did a 4n cyclization. If we try out heat के presence में 4n plus 2, अगर ये possibility try करें तो ये con-rotatory नहीं होगा. This is going to be disrotatory. So how are we going to do that? This hydrogen and this hydrogen, ठीक है, ये दोनों carbon, they are going to have a total of 6 electrons. So when you do the cyclization, both the hydrogen are going to end up on the same side. तो एक 6-membered ring भी बनेगी, and along with that you are going to have the cis junction. Alright, this is going to be somewhat like this. Now whether it is above or below, that doesn't matter. Most important thing is it is cis junction. So this looks like a stable possibility for P. 4n plus 2 और disrotatory motion ज़्यादा ठीक option है as compared to this one. ठीक है? Now what about light? Light के presence में 4n करवाना है कि 4n plus 2? एक बार एक 4n करवा के देखते हैं. 4n photochemical disrotatory. So if we are considering 4n system, तो ये दोनों protons लेने पड़ेंगे. Alright, and disrotatory means you are going to get a 3-membered ring with a cis junction. So this is a better option, still better option as compared to 4n in the presence of heat. तो आंसर इसका option number 3 आएगा, not option number 2. Also, in both the options, you cannot form this thing. दोनों option में ये चीज नहीं बना सकते because ऐसा कोई option ही नहीं दिया है. Either of the condition is going to give you this 5-membered ring also, and one condition gives you, the more stable one gives you 5-membered ring and the other gives you a 3-membered ring with cis junction. ठीक है, तो इसका option जो है वो 3rd है. Got it? बहुत easy question था guys. And this was the last question for today. We are going to have more discussion on pericyclic question, but that will be tomorrow. Okay, today at 8:30 p.m. I will see you all in another session based on organic reagents. ठीक है? Alright guys, I hope that you understand the questions which we have discussed. और अगर नहीं भी समझ में आए तो दोबारा से एक बार खुद से ट्राई कर लो. ठीक है? So that's it guys. I will see you all at 8:30 p.m. today. Bye everyone.